Alright, the last video cut a little short because I actually kind of had to redo this part, and I'm going to redo it in its own video. And I'm talking about how now with the knowledge from the last two videos, you can use that to be able to draw quick sketches that are going to help you answer problems of the derivative and double derivative, or even going backwards of a line. So let's say right here that this is the line f, or it's not a line, it's a curve. And we'll go like that, something like that. I'm going to draw the line down at all the critical end points and some more, just to make sure they're all on values. I'll go down. Okay, so what we're going to do is we're actually going to draw a number line, but we're going to draw a number line of the derivative. How are we going to do this? Well, let's go ahead and draw a number line out. So we'll do it by spaces. So this will be like 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. Okay, so this right here is f prime. So f prime, as we know, is the slope of this, and we just want to know if the slope is positive or negative. So until x equals 1, the slope is positive. If you drew tangent lines, all the tangent lines will be positive. And for that reason, we're going to do, if this is like -2, we'll do positive, -1 is positive, 0 to 1 is positive, and then it starts going negative. So then we'll start drawing negative for one more, because the slope is negative here, then positive slope, then negative slope, then positive slope. So positive then, and then negative, negative, and then positive, and then it goes positive on forever. With that knowledge, though, you can actually go ahead and draw the f prime line pretty easily. So let's go from -2. Because think about it, if f prime is positive, meaning the slope is positive here, that just means it's going to be above the x-axis in this one. So we know that from this is going to be up here somewhere, and it's going to cross the x-axis at 1, and then it's going to cross the x-axis again at 2, because it's switching positive to negative, negative to positive, then positive back to negative, so it's going to go through again here, 3, 4, and then 5 is going to cross over again. So it's actually going to look something like this. And that's what the derivative of this line approximately looks like. This is just a sketch. But have you noticed now that how you can actually use this right here to tell if something is a minimum or a maximum on the original one? Now in this case we have the graph, so we know this is the maximum, this is the minimum. But if you don't have that, then you can actually use this kind of logic to figure this out. Because think about it, if the slope is going from positive to negative, and you can do calculus to find out if it's going from positive to negative, then you would know that, well, the slope is going up and then it's going down. Whoa, that is a maximum. So if the slope is going from positive to negative, maximum, and then right here it's going from negative to positive, so there's a minimum. Positive to negative is a maximum, negative to positive is a minimum, and that's exactly what it looks like in this original graph. So you can then use that same logic to be able to find out what the double derivative looks like. I'm not going to go through all the time to do that, but you can. Then, if someone gives you information or gives you a number line of f double prime, you can use that information to find what the normal equation looks like. So let's say, for example, -2, -1, 0, 1, 2, 3, 4, I don't know. I'm just making a random number line. And let's say this is f double prime. Let's say f double prime is going to be positive, positive, negative, negative, positive, positive, negative, positive. I don't know. Then, let's say that you have another number line for f prime, which you could do work to find. I think this unit I'm kind of not doing tons of examples and just telling you how you would do things. And if there's any questions, just go ahead and message me. I know that the questions in the your work are going to be much harder. I'm just giving you like a generalization of what we're kind of doing figuratively, and then in a later video I might go ahead and do specific math. But let's say then you know that this is positive, negative, 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 positive, positive, negative, negative. I don't know. Well, then we know a couple things. We know that from this is negative infinity to negative 2, that the slope is positive and it's concave up, because the f double prime is greater than 0. So for that reason, if I drew out the line, negative 2, negative 1, 0, 1, 2, 3, and 4, that it doesn't matter where it starts, because we don't have enough information to know if it's going to be all the way up here or all the way down here. It could be really anywhere, because remember that if there's a constant, you take the derivative of it, the constant goes away, so it could literally be anywhere. But we'll just say it starts at 0. That from here, it's going up, and it's concave up, so it's going to look something like that. Then at 2, it's still concave up, but it's going down. So to do that, you're going to have a quick little point, as you can see, because it's going down, but still concave up. And negative 1 to 0, it's, oh, what am I doing? I'm sorry, it's still going, oh no, it is going down, but concave up. Okay, so it's like that. From negative 1 to 0, it's concave down and going down, so it's going to look something like that, as you see. And then we call this point right here the point of inflection, because it's going from positive to negative, which is like the maximum, or sorry, yeah, it's like the maximum of the f prime graph, if that makes sense. Alright, so then from 0 to 1, it's still going down, so you're going to draw that even further. Here, f double prime is positive, and this is positive, so it's going to kind of jut up, like that. And same thing here, so it jut up twice as far. Then once again, it's going negative, negative, and then lastly, it's like that. So that means that even though this is a very messed up graph, this is what the original graph looks like, and you used the idea of derivatives to figure that out.